In this problem, we have a 1,200 kilogram car going around a corner away from the apex 78 meters. So we are asked here to find the speed of which the car is traveling, and can we solve for this in a way that mass does not matter in our equation. So some important ideas is that we need to define our free body diagram. There is the centrifugal force keeping us on a circular path, acting in the positive x direction, and the force of friction. We know that these will be equal because the centrifugal force is entirely dependent on the force of friction. That's how we are able to actually turn a car. You exceed the amount, you push too much into the tires, force of friction, you're pushing too much force and you're just gonna skid in a direction, right? Makes sense. So let's solve here. We're gonna say that the force of friction is equal to the centrifugal force, or the force of friction minus the centrifugal force is equal to 0. So let's expand this a little bit. We know that this is acceleration in the centrifugal direction times mass, right? Newton's second law. We know that this is the static coefficient here times negative mg, so negative mass, and we'll just say gravity. Or actually, let's put it on negative gravity here. We know that we can cancel out mass here, so this is the second part of the question. Is this independent of the mass? Yes, it is. All right, so now we can just solve for the centrifugal acceleration. Negative gravity times our coefficient. Let me find a calculator here. That would be really helpful, wouldn't it? It grew legs and ran away on me, everyone. I apologize. Yeah, no idea where my calculator went. What? Okay, that's actually, it's in my pocket. I thought it was my phone. Oh my heavens. Okay. Gravity's 9.8. 1 meters a second. Negative meaning, and then we put another negative, that's a double negative, that's a positive, times 0.70, which is our static coefficient of friction. That gives us an acceleration of 6 and how many sig figs? We can keep 2 here, so 6.9 meters a second for acceleration. And then the second part of the question asks for velocity. We know AC equals v squared over r. So 6.9 meters a second is equal to v squared over the radius from the apex, which is 78 meters. All right, we're just going to bring the 78 right on over and take the square root. So I'll just show a simplification step here. Meters squared second to the negative second power is equal to v squared, right? If we have square units, we just take the square root, and that will give us velocity. So our velocity is equal to our speed going into the corner is 23 meters a second. So that's the solution to the first problem of this homework. So in this problem here, we have a 2.5 kilogram ball, 0.9 meters away from that origin of rotation. It's following a centrifugal path here, and we're told that, okay, there's a centrifugal force of 350 newtons to keep it on that path. That's what we're told. We're asked to find at what speed is the ball traveling. We're trying to find the tangential velocity, which I have displayed here, right? So there's a couple of factors at play. We should also find the centrifugal acceleration, okay? The ball's moving in a tangential way, right? It only moves in one way. That's that idea of Newton's first law of inertia, right? It's always going to stay in one direction if it can, right? So there has to be some force acting towards the center. That's what that acceleration does. It's saying, okay, ball, no, stay moving towards the center, right? So what is that? So we can define the mathematical relationship that centrifugal force is equal to the centrifugal acceleration times the mass of the object. Okay, what's centripetal acceleration equal to? Well, we know through our formulas here that if we square the speed and divide it by the radius of which, or the distance to the origin of rotation, that's also equal to AC. And then we can just times that by mass to get an equivalent equation. So in this problem, we want to solve for v squared, and coincidentally, that's the only thing we don't have. So we can just do a little bit of plugging and chugging to figure that out. So FC is 350 newtons. And just to show that the units cancel, we'll show this is in kilograms, meters per second, v squared. And then the radius is 0.90 meters. And then the mass of the object, this is equal to 2.5 kgs. We multiply the meters over, we multiply the 2.5 kilograms. We're going to get, so 350 times 0.90. This gives us 315 kilograms meters squared second squared. We divide it by the 2.5 here, the kilograms. That's going to give us meters squared seconds over second squared. So that's kind of a mouthful, ain't it? 260 meters squared seconds to the negative 2 v squared. So you can kind of see here, we have square units. We want to dumb that down to just velocity. So we take the square root and we get 3 square root 14 meters a second, which is roughly equivalent to, and we can use, let's use sig figs here, 2 sig figs. So that's 11 meters per second. So that's the velocity there, and that's the solution to this problem.